Well, hello, AP Stats students. So this is a review video for Unit 8, all right? It's a chi-square. And so let's do the FRQ for quiz 1. So question number 6, a supermarket manager wants to assess whether the actual distribution of types of items purchased in their store matches the expected distribution of types of items purchased based on industry averages. So sounds like this is a goodness of fit, whether the the actual distribution of types of items in the supermarket, right, is it of the good is it of a good fit compared to the industry averages. So the expected distribution of types of items purchased for a typical grocery store is as follows. So you have produce 12%, dairy and eggs 12%, meat and seafood 18%, dry fruit, dry goods and packaged foods at 58%. So it should add up to 100%, right? All the four different categories. Okay. So so this looks like it's goodness of fit. It comes from one population with one sample from the supermarket, right? Okay. Let's get rid of this. So the manager randomly selects 1,923 items from the store's purchase database and records the type of item. The observed frequency of types of item purchase are as follows. So fresh produce. So you have an observed list here, right? Observed count from the four categories of the variables in the supermarket. Do the data provide convincing statistical evidence that the distribution of types of items purchased at this grocery store differs from industry averages? Conduct an appropriate statistical test to support your conclusion and include a follow-up analysis if appropriate. All right, so let's proceed. So first of all, we have to do the four-step process. So the first step is state. So we write the name of the procedure, which is chi-square test for goodness of fit, add a alpha of 0.05, right? Since it's not stated, we set the alpha at 0.05. Then we need to put the hypothesis. So the null hypothesis is the distribution of purchases at this grocery store follows industry averages. And the alternate is just simply doesn't follow, right? So HA equals to what is the distribution of purchases at this grocery store does not follow industry averages. Okay, after that we proceed to the plan, right? And plan, first thing is we need to check if the sample was random. And the sample is indeed randomly selected, 1,923 items. So you have to give some kind of context. You cannot say sample randomly selected. You have to say something that indicates that you know where the sample is coming from. So in this case, it's 1,923 items. Second thing is the 10% rule, right? The independence rule. And that is that you take the sample size, which is 1,923, is less than equals to 1/10 of, so in context, where the items from. So items came from a population of all the items purchased, right? So then the large counts. Now this is tricky because, right, I mean, here we're putting on the expected counts. Now you have to do the expected counts on your own somehow. Either use a calculator, you have to put the observed counts into a list, and then calculate the expected count separately, one at a time, right? So all expected counts. Now I'm just going to write out the numbers. Is 130.76, 230.76, 346.14, and then the last category is 1115.34. They are all greater than 5. Okay, so conditions are met. We go to the next step, which is to do. Then you need to calculate the chi-square statistics. Now, here you can put a generic or specific formula, which is the chi-square formula, right? It's the observed minus expected square divided by expected, but then you have to put the summation sign before that. So let's write it out, right? Chi-square statistics is, we put in the numbers. We can put the first one. The first one is 193 observed count minus the expected count to 130.76. Square it, divided by 230.76. Now here, this actually you do not need to write all of it. You can just write plus dot 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 plus and then write the last one. Okay, so it's 1173 minus 1115.34 squared divided by 1115.34. Then you calculate each individual category with there are 4, and you add it up. The chi-square statistics is 40.55 with the degrees of freedom. Categories minus 1, which is 4 minus 1, then that equals to 3. So the p-value is, you can use chi-square CDF, or you can use the calculator function, right? But here, if you use CDF, you have to put in the 3 parameters, which is the lower bound, and here the lower bound is 40.55, and the upper bound, which is 99999, and then degrees of freedom, which is 3, and that comes up to a very, 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 very small number. So here the calculator says 8.14 times 10 to the power of negative 9. So it's really, really, really negligible. So conclude. Since p-value is less than 0.05, we reject the null hypothesis. There is convincing evidence to conclude HA, right? And what is HA? HA is the distribution of purchases at this store is different than industry. Now, we are supposed to calculate, they say, include a follow-up analysis. And here the biggest component is the 17.19. And that came from where? That came from the number of, which category? It was the meat and seafood department. And why is that? Because the observed count is actually much, much lower than the expected. Okay, so part B, which type of visual display could be used to show how the observed distribution of purchases differs from the expected distribution of purchases? So this one is actually, you can use a segmented bar chart, right? This would show the relative frequency of purchases from each category according to industry and from the sample data. So for example, now this is not drawn to scale. So I'm drawing you to, it's a segmented bar chart. It's like, it's the whole bar is like 100%. And in this case, it consists of 4 categories of items purchased, right? From 4 different departments. So you can see that each department occupies a certain so-called ratio or proportion of the whole entire bar. So then you can see which category, which one is observed more or is expected more. So you can use a segmented bar chart to actually show, use it as a visual display. Right, thank you. Okay, so now we continue with the FRQ for the second quiz, right? And so question number 6, a study conducted by the Humanitarian Aid Organization, the UNICEF, sought to determine what young adults in different countries viewed as the most important factor in determining success. Independent random samples of 1,000 young adults aged 15 to 24 in 21 countries were surveyed and asked whether education, hard work, or family wealth / connections was the most important factor. The responses for 2 of the countries, the US and France, are given in the table below. So you see that this is a two-way table, right? One of the categories are factors determining success. All right, there are three variables. One is education, one is hard work, and one is family wealth and connections. Wouldn't that be nice to have some family wealth? And then the other variables are the countries. So in this case, we have the U.S. and France. Okay. So, part A, do the data provide convincing statistical evidence that the distribution of responses differs for young adults in the US and France? So you see that there are two separate populations, one population from US, one population from France, and you have two separate samples, one sample from US, one sample from France, and within each sample they are being asked whether those 1,000 people in the U.S. what they think are the determining factors, be it education, hard work, and family wealth connections, and the same question is being posed to the people in France, the 1,000 people, the 1,000 people sample in France. So two population, two samples, one variable. So this is a chi-square test for homogeneity. So we'll work this through and try to answer this question. I should put it like this. Thank you. Okay, so let's proceed with the four-step process. So first step is to state, right? State. And we need to put the name of the procedure, which is chi-square test for homogeneity. But we also need to include the significance level. So at alpha or equals to 0.05. Then we need to put the hypothesis. So the null hypothesis H naught is there is no difference. Usually, always we put no difference for the null hypothesis, right? No difference in the distribution of responses between young adults in the US and in France. Alternate is very simple. It just says there is a difference. So there is a difference. Same thing, you just copy exactly from what you wrote for the null hypothesis. You just change from there is no to there is a difference. And then we do the plan, right? Next step is the plan. Plan, there are three conditions, the random. So random unique context, right? You need to put independent random samples from people from US and France. In fact, instead of people, I should have written young adults. So independent random samples of 1,000 young adults from US and France respectively. So that's to add more context to this group of random condition. Second is the 10% rule. And this one, all right, we put the sample size 1,000 is less than equals to 1/10 of all young adults in the US. And then we need to do the same thing for France, right? 1,000 less than equals to 1/10 of all young French adults. And then we do the large counts. Now, this is always tricky because you have to kind of do it beforehand, or you have to do it by hand, or use the calculator. So all expected counts, you have to do this by hand, and then you have to write it out. If you don't, it's not going to be counted as credit. So you got to put down the expected counts, 303, 303, 415.5, 415.5, 281.5, 281.5 they are all greater than 5. So the next step is do. So you need to put the chi-square formula. If you remember how to put it down, it should be on the formula sheet, right? So you put it down, then you write out the values. So you can write the first one, 243 minus 303 squared divided by 303. Then you can put plus, dot, 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 plus, and then you can put the last one down. It's not a problem. And then it adds up to 55.3849. You can get this from your calculator. You can also get the p-value from the calculator, but if you want to do it by hand and to confirm it, you can use the chi-square CDF, you need three parameters. You need the lower, the upper, and the degrees of freedom. In this case, is 2. Degrees of freedom for chi-square test for homogeneity is row minus 1. So in this case, 2 minus 1 is 1, and then column minus 1. So we have 3 columns minus 1, which is 2. So 1 times 2 is 2. So it's very, very small, 8.14 times 10 to the power of negative 9. So it's really negligible, right? So conclusion is, since p-value is less than 0.05, we reject the null, right? That there is convincing evidence to conclude what? We always to conclude or not, we always say there is convincing evidence or not convincing evidence to conclude HA. And what is HA in context? Is the fact that there is a difference in the distribution of responses between young adults in the US and France. Now, this is statistically significant. Now, sometimes they'll ask you, okay, if it's statistically significant, what are the big components? What's the biggest contributing factor? And the largest component here of chi-square was actually 15.71, and that's contributed by the group of family wealth and connections, because the number of young adults in the US is much lower than the expected ones for France. Right, second part to this question, part B. Based on your conclusion from part A, which of the two errors, type 1 or type 2, could have been made? So what happened to part A? So we reject the null. Since the null was rejected, right, a type 1 error could have been made, right? Remember our type 1 error, our class examples of sending an innocent man to jail? Well, we rejected the null hypothesis that he's innocent, and we send him to jail. So type 1 error could have been made in this case. Now, this means that we concluded that there is a difference in the distribution of adult responses between US and France when there is not. So this concludes the Unit 8 review. If you have any question, please check in with me. Thank you.